Hi friends, let's begin our session. I hope my screen is visible and my voice is audible. Now let's continue our discussion on Docker run command. Docker run command is used to run a container. To run a container, we need to have the container image present either locally in the Docker host machine or it should be present in the Docker hub. Now, yesterday we have seen how to create a container and how to stop it, how to remove it, how to restart it, how to interact with the container shell, how to create a file inside the container, how to remove image, how to remove all the containers at once, how to remove all the images at once. All those commands we have seen, which are very important to debug any issues in the real time. Now, we will see few more options with the run command. Okay, so now what we will do is, now let's try to pull Tomcat image. How to pull Tomcat image? We know that Docker pull command is the one which is used to pull a Docker image. This image should be present in the Docker hub. Then to list out the images, we can use this one, or Docker image, ls we can use to pull Ubuntu. We will be using Ubuntu to pull Jenkins. We need to use Docker pull, and that particular image name we have to give. Now, today we will understand port mapping and other things. This is our Docker host machine. We are running a container. Yesterday we ran Ubuntu container and we also ran what? Nginx container. Any container we can run provided that we have the relevant image in the Docker hub. Now, if I create Tomcat container, what it will be having? Tomcat container will be assigned with some internal private IP address, right? So now let's try to run the Tomcat container or Nginx container. Docker run. Now let's name the container as C1. Then we need to provide what? Image name at the end, colon the version of the image or the tag of that image we need to provide. And to run this container in the detached mode, we need to use -d. Because we didn't pull that image already, that image is not found locally. That's why it is being pulled from the Docker hub. So once that is done, to check the containers, we have Docker ps or Docker ps-a command. Here the container name is C1. Now, if we inspect it, Docker inspect C1. If we inspect it, see, we can see that this particular container is attached to bridge network. We will understand this later. Now, if you observe here, this is the private IP address of that particular container. Okay, so the container name is C1. This is the IP address. The IP address is the private one. Then how to access this front-end application outside of this host machine? We saw that how to access this internally. For that, curl the IP address and the port. Port is 80. Okay, if you do that, see, we are able to access the Nginx application. And yesterday we have created some Ubuntu container. We have installed curl in that, and we try to curl the IP address of the Nginx, and we have seen that that IP address is accessible because that content is present in the same host machine. But how to access this Nginx outside of this host machine? What if I want to access from my local or from anywhere in the world? For that, we need to perform port mapping. So performing port mapping means this is the container that is running. The container port is what? It is 8080. This is the container port. How do we know that it is 8080? Docker PS. If you see here, this is the port. The port is 8080. Right? Now, port mapping means we will map this port of the container to some port on the Docker host machine. Okay, so we will map like this. This is the port. Sorry, friends, this is 80, right? Nobody is talking. This is 80. This is the port of the container. Now, what we will do is we will choose some port on the Docker host. It can be anything. Now, let's say it is 8080. So this 8080 port, we will map to that particular port of the container. Nginx application is running inside this particular container. Now, this Nginx got some private IP address. This is the one. Now, because this is the private IP address, we can't access this particular application outside of this host machine. To make it accessible, we need to perform port mapping. How to do that? We need to map this port of the container to some port on the Docker host Docker host. And this port can be anything. This 8080 or it can be 9090, any port you can give. Now, how to perform this? For that, now let's try to run another container. Why this is not smart? Docker run. Now let's name this container as C2. Now let's use the same image, that is Nginx latest image. Then -b to run the container in the detached mode. Then how to perform this port mapping? For that, we need to use P option. P stands for port. So to perform this kind of port mapping, we need to give the container port first, and to which that we need to specify after colon, right? So this is how to perform port mapping. Let's go and check. So it is other way around, friends. First, it should be the host. What happened? Fortunately, disconnected with my. Why this machine is too secure? Right, Docker PS. This remote machine is not responding smoothly, friends. Seems like Docker PS. This is the port. Now, how to perform this port mapping? Now, let's create another container. Docker run, name of the container. I want to give the name as C2. Then, after that, to run the container in the detached mode, we will be using D option. Now, at the end, we need to provide the image name. This should be provided. Then, how to perform this port mapping? Small p stands for port. Then what port, which port of the host you want to choose? It is your choice. I want to choose 9090 here. And map this to port of the container. What is the container port? Container port is 80. Now you will be getting some doubt like, because some container, Nginx container is running and the port is mentioned here. That's why I'm making that here. But what if that container is not already running? What I meant to say is how to recognize the port of the Nginx. For that, you have to go to the description. In Docker Hub, if you search for Nginx image, documentation will be provided. In that, the port of this Nginx application will be mentioned. Here somewhere. Somewhere it will be mentioned. See, here it is mentioned. Or even if you go to any official documentation of the Nginx, you will find that the default port for Nginx is 80. So that port I'm choosing here, and this is the port that I'm choosing from the Docker host, right? Then hit enter. With that, this C2 container will be running now. Now, if you see, if you give the public IP address of the host machine, okay, so this host will be having public IP address. Where is it? If I go to AWS instance, if you click on this, this is the public IP address. You can use either the IPv4 DNS or the IPv4 address itself. This is the IP address of this host. Now, if you hit IP address with the port that we have chosen on the Docker host, now traffic will go to this container and it will be accessible now.
Sir, this port number are fixed for every application?
No, it's not fixed for every application. I'm doing some mistake here. It is 9090.
No, whatever the 80 number is, 80.
This 80 or what? Or
80,
the one that we
80.
have chosen?
No, 80 is
it depends on application.
Okay, so if
This 80
another
is
application, if two,
predefined.
okay, so suppose if we have two applications, okay, and if they have both have the 80 as a port number, so is there any problem?
No issues.
No issues. Okay, because we are mapping with the different ports.
Different port on the host.
Okay, got it.
Now, if I give this IP address to you, you may be anywhere in the world, you should be able to access my Nginx application. You can try it. Now, what I will do is, I want to interact with the container terminal and I want to modify the content that is being served for us. Here, this is the content that is coming. What I will do is, I will go to the container. The container name is C2. This is the command we use. Docker exec. IT stands for interactive mode. Exec stands for executing commands. Then C2 is the container name, and we need to provide the shell path. Now here, if you know already from where this content is being served, what is the location of this particular file? That the location of that file is cd user share nginx html. This is the path. Here we have index.html. This is the content that is being served. Now, what I will do is, I will modify this content. I will remove this altogether. Now, I will create some file. Hello all. Now, I will redirect to index.html file. Now, I'm not doing anything here. Just I will go and refresh it. See, we see that is reflected here. So that is how we will be interacting with the containers. But real time, are we going to do this? No. What we will do is we will copy the application source code into the container, and that we will build inside the Docker image itself. Okay, so that we will see in the Docker file. Now these are the basic steps to understand all those things. Now we are exiting from this. That is how to perform the port mapping. If you take Jenkins will be having its own default port. Now let's try to run Jenkins now. See, here it is saying that the first one is deprecated, so we shouldn't use it. Instead, this is by the Jenkins. Now we will be getting some doubt like why it is Jenkins/Jenkins instead of just Jenkins. This is the organization ID. We will also be creating our own IDs when we are building our own Docker images. Right now, let's pull this Jenkins/Jenkins. What I told is you don't need to pull the image already. When we are performing Docker run command, Docker will try to search for that image locally. If it is not found, it will directly connect it to the Docker hub. By design, Docker will be connected to the Docker hub. Later, when we are playing with our private container registries, we will be having different mechanism to authenticate to the container registry. So what I said is Docker hub is the default public container registry, which is inbuilt with the Docker. Now, how to run this Jenkins? That we will see now. Docker run, name of the container, you can name anything. Now let's name the container Jenkins itself, right? Then what we need to provide? We need to provide the image. And here, as a best practice, we need to mention the tag also. If you are not mentioning any tag or the version, by default, it will be treated as latest. Now, let's run this in detached mode and perform port mapping. Small p. Now, this time, I don't want to choose this host port. I'm not choosing this at my will. I'm leaving this to Docker to choose some port on the host. For that, we have the concept of automatic port mapping. Here, we need to just give capital P. And here we shouldn't mention, we should not mention the either host port or the container port. Okay, we just have to leave it. This is called automatic port mapping. In this, what will happen? Let's see. The Jenkins image is not found locally, so it is being pulled from which server? From Docker hub. And images will be pulled in the form of layers. We will understand this later. Layers concept. For that, we need to understand Docker file first. Then only we will understand this. Now, Docker PS A. If you see, if I run this command again, here this is the Jenkins container. See, whatever the ports that are exposed in that container, all will be mapped to some port of the host. And this 8080 is the port on which Jenkins will be running. This is the port of the container, and it is mapped to some port on the host. Who mapped it? By default, it is mapped because we are using the automatic port mapping. Right now, we should be able to access Jenkins on this 32769. The IP address is what? Host IP address. Host IP address, and what is the port? 32769. 32769. See, our Jenkins is up and running. How quickly Jenkins is up? If you want to perform this in non-containerized world, you know the steps. First, we need to install Java, particular version of the Java. Then we need to run just 10 to 12 commands to install Jenkins. In those things, there is no guarantee that Jenkins is up and running. But here in the concept of containers, Jenkins image is already present in the Docker Hub. And who created it? The Jenkins organization has created it, and it is made available for the public. And Jenkins is an open source software. You know that already. Now, if I give this IP and this port to you, you will also should be able to access. You can access my Jenkins server on that IP and port number. So this is how we will perform the port mapping. If you are using Docker Compose, if you are a developer or a DevOps engineer, you will be using Docker Compose. There, this concept will be useful. Okay, how to perform port mapping, there also we will discuss. And in Kubernetes also, we will discuss all these things again. Now, that is one option with the Docker run command. Now, what if you want to pass environment variable to the application? For that, we have another option called E. This thing we already saw. Okay, here the image is different. It is Tomcat server. Now let's try to execute this. We are trying to run Tomcat in the form of a container. And before that, I want to remove all these things. RM F we need to use because the containers are already running. If you want to remove them, first we need to stop and remove, or else you can use F option to forcibly stop, and to remove we have RM already in this C1 space C2. So with that, the two containers will be removed from the host. I think only C1 and C2 is there. This Jenkins is also there. After RM Jenkins, this name we didn't provide. So because this is running, we can't just remove it. We need to apply force, or we need to stop the container first. I'm just applying the force. Now let's try to run Tomcat application. Docker run. What's the name of the container you want to give? That we need to mention here. We are naming this as web server, and we are performing port mapping. Small p for manual port mapping, and in case of manual port mapping, we need to give the host port, and if it is automatic port mapping, we need to mention capital P. In that case, we should not mention this. Right now, the image is Tommy, and we want to run the container in detached mode. So with that, Tomcat will be up and running 7070. The port is 7070. And before that, now let's ensure that container is running. That container is running. The port is 7070. See, Tomcat application is running successfully. So this is how to launch the containers. Now we will explore few more options, and they're very important also. So this we have seen Jenkins, and these options you can interchange. Okay, it's not something like you need to follow some order. Options, you know, we can interchange them also. Now let's take a scenario. Start Nginx as a container. To start Nginx as a container, first what we need to have? We need to have the Nginx image, either locally or in the Docker Hub. Now name that as app server. How to name it? Name it as app server. We need to use name flag -- name. Then we need to give this. Run this in detached mode. Detached mode means we need to use -d. Why to run them in detached mode? Because you want to push the container to background so that you will be able to run other commands here. Now, what I will do is just to remind you this again. If I don't use -d, now let's run some C1 container. Now let's use Nginx. Now I'm not using -d. What will happen? The logs will be shown like this. Okay, so they will be streamed on the console, but you won't be able to run any other command here. You won't be able to run this. So in order to avoid this, we need to run the container in the detached mode. For that, option D is there. That is detached mode. That is one thing. Capital P we have seen for automatic port mapping, and container ls or container ps, anything you can use. Better to use docker ps command only, because that docker ps command will be having a option to see stopped containers also. Now, if you want to run CentOS container, then docker run name of the container, and because it is an operating system container where there is no application running, we need to interact with its shell. Then we need to provide the image at the end. Now, this we have seen in case of Ubuntu. Now let's see database. How to launch MySQL database using a container. Now, for that, we know Docker run. The only thing that we need to have is the Docker image for that. Now, if I go to Docker Hub and if I browse for MySQL or any favorite database, now see MySQL. This is the Docker official image. MySQL is a widely used open source relational database management system, and it is updated 3 days ago. And these are the number of tools for this. And this is MariaDB, Percona. So different things are there. About 10,000 results were there based on customization. They are customized. Here, this is from the Docker official image. So in real time, we will also be customizing the existing images that we will learn during the Docker file section. Now, if you click on this, here it will be giving the pull command, but we are not worrying about the pull command. Now, here we will be having another option, that is E. We want to run a container, name that container as MyDB. This container name can be anything. It can be your name also, but it should be meaningfully given. Then we are running the container in detached mode. Then how to pass environment variable to the container? For that, we have E option. E stands for environment. And this is the environment variable used to pass the password. Okay, so E, and we need to provide that variable. Then what is the value that you want to assign? That you can assign like this, is using equals operator. Then at the end, we need to provide the image and the relevant version. Now let's run this. Note that I want to remove any content is there to reduce the load on the machine, because the machine is already running slow. It would have need a money, but that is removed. Now, Docker run, name of the container, I want to give it as MyDB. D option to run the container in detached mode, and this is the one that we are going to learn. So MySQL root password, the password we are providing is Laxman. So now you will be getting some doubt like, how do I know this? Again, we need to go to the description of that particular image. If you go and check here, this is the environment variable for providing the password to the database, and we are providing Laxman as the password. Now let's hit enter. So with that, the MySQL with the tag 5 will be pulled from the Docker Hub, and after that container will be created, and that container will be named as MyDB. Now, if I use Docker ps command, see MySQL container is running, and the container name is MyDB. This is the image that is being used. Now let's interact with it. How to interact with the database? Docker execute commands in interactive mode, exec it. Then what is the container name? MyDB enq bash here. With that, we are into the container terminal. How to connect to the database? For that, we need to know database commands. See, to connect to MySQL database, MySQL user, the default user is root, and you provide password. It will be asking for password. What is the password that we have provided? It is Laxman. If I give this, see, we connected to the MySQL database. Now we can play with it. Now I want to get the list of all the databases in this. So for that, show databases command is there. So these are the databases that are we are already connected to MySQL database, which is the default one. And you can do anything that you want to do with the database. You can create schemas, tables, and you can run any database related query. So this is how to launch the MySQL database using the container. How quickly it is launched. Same thing, if you want to run PostgreSQL also, oh, friends, unfortunately, it is disconnected. PostgreSQL. Is it not? I think this is the PostgreSQL. See, PostgreSQL and Postgres. This is the image for the PostgreSQL database. Okay, and what we have to do, we have to use Postgre instead of that particular image where we have used MySQL. As simple as that. So you can run any container, any application in the form of container, provided that application image, application container image is there. Either it can be there in the Docker Hub or it can be there in any container registry. And for that container registry, you should have the credentials. Now, we will explore few more options.
So how can I connect to the MySQL database from my local application?
You want to connect from your local application, right?
Yes, sir.
So
MySQL.
for that, we need to perform port mapping. Okay. And if you are using, if you have some backend application here, if you want to connect to it, what we have to do is we have to create a network. We have to link it. Then that container name will act as the host name, and with that host name, the application will be connecting to the database. We'll see WordPress example now. So there. Now we have run the individual containers, but in real time, no application is independently running. The application will depend on another application. For example, there is some backend application. Backend application needs a database. For that, there should be a proper communication between them. And at the same time, if front-end application wants to communicate with the backend, there should be communication. How to establish that? For that, we have two options. One is link, another one is network. And here the concept is creating multi-container architecture. Multi-container architecture means instead of running single container standalone, we will be creating multiple containers and we will be linking them based on the requirement. Like we will be linking backend service with the database. We will be linking backend service with another backend service or multiple backend services, or we will be linking the front end with the backend. So how to make that connection? For that, there are two ways are there. One is link, another one is network. And this Docker Compose is different. We cannot categorize linking containers in these two ways. We can make the communication possible between two containers using either link and network. And network is the advanced one, and Docker is not recommending to use link. But if you have some script, older Docker scripts, you will be finding that link is there in that. So now let's learn link. Even though if you are not using this in the real time, now let's use this, because before this network object is invented, this link is there. Now, even though it is there, some people will be using link here. So what is this link? Now, let's try to run two BusyBox containers. What is BusyBox container? BusyBox is a Docker image which combines tiny versions of many common Unix utilities into a single small executable. That means it's a Unix Docker image, but which contains only tiny versions. What does it mean? Now let's try to pull Ubuntu image, Docker image ls, Docker image ls. Here we don't have the Ubuntu image. Now let's pull Docker, pull Ubuntu.
Sir, your screen is not showing.
My screen is not visible.
No, means it's visible. It's only on that text document right now.
Oh, is it? I'm in terminal now.
Yeah, that's why I said.
Yeah. Raman or anybody, could you please confirm whether you are able to see my terminal, Docker host terminal?
It's a document only visible, not terminal.
Google
Yes,
Docs.
okay. I will reshare my screen. Here, weather is what not good. Due to that, some network issue may be there. Now you can see my terminal, right?
Yes.
Yeah. So we are pulling the Docker Ubuntu image, Docker images. See here, what is the size of this Ubuntu image? It is about 78 MB in size. Now let's try to pull BusyBox image. Docker pull BusyBox. You pull this, and if you compare the size of the Ubuntu and this, where is it? BusyBox. How much is its size? It is about 4.2 MB in size. Why? Because these two are Unix based Docker images only, but in this BusyBox we will be having tiny versions, very lightweight versions of the commonly used Unix utilities. That's why it is lighter in size. If it is lighter in size, means the boot up time will also be very less. That means container will be launched very faster. And at the same time, the Ubuntu image will also be pulled very rapidly if the size is very less. Now let's create BusyBox container. Docker run, name of the container is BusyBox1. We are naming it as BusyBox1. And because it is an operating system based container and no application is running inside of it, we need to interact with it. Then we need to mention the image name at the end. If you do this, BusyBox1 container is created. Now we are interacting with it. Now let's come out of it. Control PQ. We came out of it. Now let's create another BusyBox container. And we are naming that container as Docker run BusyBox2. And let's interact with it. Now forget about link. We'll come to it later. BusyBox2. This is not responsible. And it seems like some connection issue. I connected to ISP network only, but some interruption is there today. Docker run, name it as BusyBox2, and the image name is BusyBox. And I want to use the latest one. That's why I'm keeping no tag. We are interacting with it. Now let's interact with it. So we are interacting with the BusyBox2 container. Now let's exit from this. Control PQ. Now what I will try to do is I will go inside of BusyBox2. Observe carefully. And before that, I want to get the IP addresses of these two containers. How to get it? Docker inspect BusyBox, BusyBox1. Docker inspect.
It's O, sir, there. So you in BusyBox. BO.
Yeah, yes. BusyBox1. Here we have the IPv4. This is the IP address of BusyBox1. Now let's inspect for BusyBox2 also. It will be having its own IP address. BusyBox2. See how the IP addresses are? They belong to the same network. This is the network part. This is the host part. Now I will interact with BusyBox2. Docker exec IP BusyBox2 cache. See what it is saying is OCJA runtime executable file. Here executable file not found in the path. So what it is saying is when we are trying to use bash here, it is saying that that executable is not found. So when we are giving something here, how it is reading, we will understand once we understand the Docker file. So now what I will do is I will use just a simple shell. And we already read that BusyBox is a Unix based operating system which contains tiny version. So bash is somewhat higher one, heavier than the shell. So shell is only sh will be existing in the BusyBox, not bash. Now if we hit enter, this time it should work. Now we are into the BusyBox2. Now let's try to ping busybox1. Busybox1 with the container name of the busybox1. Busybox1. Bad address busybox1. That means busybox1 is not recognized by the busybox2. That means busybox2 is not able to communicate with the busybox1. Now, how to make this communication possible? And now let's try to connect to busybox1. That means now let's try to ping busybox1 with the IP address. What is the IP address of the busybox1? This is the busybox1 IP address. Now we'll give it a see. Ping is working. Now I'm obstructing it. Then what is the conclusion here? Busybox2 is able to communicate with the busybox1 with the IP address, but not with the container name. And container name is nothing but the host name in the container world. Now, in containers, we don't rely on the IP addresses. Why we don't rely on the IP addresses? That you will understand when we are running the scaling. When we are scaling the containers, we will be running the same application in multiple replicas. So there you will clearly understand that relying on the IP addresses is not ideal solution. So we need to make communication in such a way that the containers are able to communicate with each other with their container names. Container names are also nothing but the host names. Now, how to make this connection possible? For that, we have a concept called link. How to link container from this busybox2 and remove it. Now, once we exit Docker RM, better I will switch to different network, but as we are already at the end of the session, I'm not doing that. Busybox2. We have removed the busybox2. Now, you see only busybox1 is running. Of course, this MyDB is also running. Now let's remove that database. Now, I will try to run busybox2 and I want to link that busybox2 with the busybox1. How to link it? Now, what I'm trying to do is I want to run another container called busybox2. Now the busybox container, busybox2 that we are going to create is new one. We are not going to get the deleted busybox2, and here we will be getting the new busybox2, busybox container. Now, how to run it? Docker run, name the container as busybox2, and we need to provide the image name at the end. Then we need to interact with it. And apart from that, what we want to do is we want to link this busybox2 with the busybox1. How to link it? For that, we have link option. Link. Then what we have to give is link with busybox1. Busybox1 has to be given here. Sorry for the inconvenience, friends. I think host is not responding properly. It may be due to network interruption here. Link with busybox1. Busybox1. And this busybox is nothing but what? This is the image name. And we want to link this busybox2 with the busybox1. How to establish that? Link option is there. and we need to provide the container name to which we want to link this container to. Then here you can give alias name. Alias name means you can name that link differently. Okay, this we will understand later. Don't want to confuse. Now we are into the BusyBox2. Now let's try to ping BusyBox1 with the host name of BusyBox1 or the container name. Now ping is happening. I'm interrupting this. Why earlier it didn't happen? Because by default, containers won't be able to communicate with each other with their host name. To make the communication possible, we need to link the containers. And this is the legacy version of the linking the containers, which is not being recommended by the Docker. So we have another concept called network, where we will create a network object, and to that network object, we will connect the containers to which we want to establish communication. That we will see in the network concept. So I want to close this session little early, friends. Let's meet tomorrow. Okay. And please complete your payment formalities as soon as possible, so that they will be creating Google Drive link for you, and notes and videos will be shared there. Right. So tomorrow, Saturday, we will be having class. Only on Sunday we won't be having the class, and from Monday link will be changed. Okay, new link will be created, and that link will be available only with the students we have paid for it. That's all for today, friends. Thank you.
Can I ask you one question, sir?
Yeah, please.
Right now we have image means we have first image, right? And we link second image when we are installing, right? So is it possible that both image are already installed, means pulled, and later we are linking them?
No, that is not possible.
Okay, so same
That
time
is
when we pull, then that time we need to link.
Yeah. So why? Because we are not going to run the containers in this format also. We will be using the Docker compose file to link multiple containers. There we have to define all the things in the YAML file. Okay.
Okay, so in that case we can able to achieve that.
Yeah. No, we can't achieve. Once the containers are already running, and if you want to link them, you can't. Okay. When they are being created, that time itself, you can link the containers.
We need to define. Okay. Okay.
Yes.
Thank you.
Yeah.
So now can we access the BusyBox2 from BusyBox1? Like, or we have to the opposite command on the BusyBox1, linking command.
Didn't get you.
So now, so currently you have executed the command to connect the BusyBox1 from BusyBox2, right? So
Yes.
will this opposite? In this case, can we
This won't work.
opposite? Okay. So we have to execute this command BusyBox1 now for to.
Yes. So if you want to connect one container to another container, this thing. So those are some drawbacks in that. So that's why maybe Docker came up with the concept of networking, which is used in the real time, and that link is the legacy version. Docker is not recommended, and it will be removed in the future. Okay. Yeah, that's all, friends. Let's meet tomorrow. Thank you.